In this video, we'll find vertical and horizontal intercepts for a logarithmic function. Remember that our vertical intercept is going to be the point that's associated with having an input of 0 into our function, and the horizontal intercept is the point associated with having output 0 in our function. It's easy to remember because the inputs are the x-coordinates and the outputs are the y-coordinates, and so you can just think about what type of coordinate would be on the x-axis or the y-axis and understand which one is which. Anyway, there's going to be one of each. Anytime we know our input, the output is straightforward to find because knowing the input just means putting the input into the formula for our function in place of x. So I'll have the log base 2 of 0 plus 3 plus 2. So that will be the exact value of the output when the input is 0. In this question, it asks us to find those numbers rounded to 2 decimal places, and we're in a situation where we have to calculate a log base 2, and most calculators don't have a log base 2 button. So we have to remember that any logarithm can be calculated using this fact that it's the log of the argument over the log of the base. So this part that I've highlighted here is just the formula for calculating this value. So that's generally called the change in base formula, but it really is just the way to make your calculator evaluate a logarithm with any base. And so when I put that in my calculator and round to 2 decimal places, I'll have 3.5. Oops. So that ends up being about 3.58. So my vertical intercept is 0, 3.58, rounded to 2 decimal places. The horizontal intercept always involves solving an algebra problem because we have to figure out what the input should be for the output to be 0. So the question is, what is the input so that the output is 0? This equation we can solve by first, the equation here, we can solve by first isolating this logarithmic piece. And to do that, I would subtract 2 from both sides, which makes this go away. And I'll have the log base 2 of x plus 3 equals negative 2. And so that's our basic logarithmic equation form, which means that we can write down an equivalent equation using an exponential with the same base. So the base for the logarithm is base 2, so the base of my exponential is going to be base 2. And in the exponential equation, we'll find that the role of the input and output for the log equation have been reversed. So I'm going to want to have these two things reversed. So I'll have 2 to the negative 2 equals x plus 3. So I'm going to pick that up over here. 2 to the minus 2, if you put that in your calculator, you'll find that that is 0.25. It's just 1/4. So I'm just going to leave it as 1/4 for now, equals x plus 3. Now, to get x by itself, I'm going to subtract 3 from both sides. And as usual, this is gone, and now I finally have just the x left on the right side. On the right side, I have 1/4 minus 3, which is negative 11/4. We do want that to be a decimal to 2 decimal places, and so we can put that in our calculator and find that's negative 0.275. So my horizontal intercept is negative 2.75 is the value of x, and 0 will be the output.